Hello everyone, welcome back to my YouTube channel. As you all know me, I am Anujias, currently pursuing in the third semester in the Department of Computer Science and Engineering at SVCE Bangalore. Today my subject is mathematics and today's presentation is on test of significance for means of two small samples. Yeah, test of significance for means of two small samples. Comparing the means of two small sample groups is a common statistical analysis. This test helps determine if the difference observed between the sample means is statistically significant, providing insights into population level differences. Yeah. Now let's see introduction to hypothesis testing. Hypothesis testing is a statistical method used to make decisions or inferences about population parameters based on sample data. It helps determine whether there is enough evidence to reject a null hypothesis in favor of an alternative hypothesis. Here is a brief overview of the key concepts. One is null hypothesis, the assumption that there is no significant difference between the population means. Second is alternative hypothesis, the hypothesis that there is a significant difference between the population means. Third one is test statistic, a numerical value calculated from the sample data of the null hypothesis. Now, assumptions for two sample t-test. Independence of observations. The samples must be independent of each other. This means that the data collected from one group should not influence or relate to the data collected from the other group. Second one is normality. The distribution of the sample means should be approximately normal distributed. This assumption is particularly important when sample sizes are small, typically n less than 30. For larger sample sizes, the central limit theorem suggests that the distribution of the sample means will approximate normality even if the original data is not normally distributed. Third one is equal variances. The variances of the two populations from which the samples are drawn should be equal. This can be tested using Levin's test or an F-test. If the variances are significantly different, a variant of the t-test, Welch t-test that does not assume equal variance may be used. Scale of measurement. The dependent variable should be measured on an interval or ratio scale. This means that the data should be continuous and have meaningful numeric values. Fifth is random sampling. The samples should be drawn randomly from the population to avoid bias. This helps ensure that the results are generalizable to the larger population. Test statistic and degrees of freedom. Test statistic. Calculated value used to evaluate the null hypothesis. Degrees of freedom determines the t-distribution used to find the p-value. Calculating the test statistic. Sample means calculated from the two sample datasets. Sample variances measures of dispersion within each sample. Sample sizes number of observations in each sample. Hypothesis formulation. Hypothesis formulation is a critical step in the hypothesis testing process. It involves stating the null and alternative hypothesis clearly. Here is how to formulate them effectively. Understanding the concepts. Null hypothesis. This hypothesis posits that there is no effect or no difference. It serves as the default assumption that the research seeks to test. Alternative hypothesis. This hypothesis represents what you want to prove or support. It indicates the presence of an effect, a difference, or a relationship. Considerations for formulation. Specificity. Be precise in your wording to avoid ambiguity. Measurable. Ensure that the hypothesis can be tested through statistical method. Relevance. Align the hypothesis with the research objectives and context. P-value and interpretation. P-value, probability of observing the test statistic or more extreme under the null hypothesis. Second is interpretation. Low p-value, that is less than 0.05, suggests the null hypothesis is unlikely, leading to rejection. Effect size and practical significance. Effect size, magnitude of the difference between the means independent of sample size. Practical significance considers whether the observed effect is meaningful in the real world. Limitations and considerations. Sample size. Larger samples are more powerful but may not always be feasible. Assumption violations. Violations can impact the validity of the test results. Interpretation. Statistical significance does not always imply practical or clinical significance. Finally, the conclusion and key takeaways. The two-sample t-test is a powerful tool for comparing means between small samples. Understand assumptions, interpret p-values, and consideration effect size and practical significance. In conclusion, this study aimed to compare the means of two small samples to evaluate the impact of a new teaching method on student performance. The two-sample t-test revealed a t-value of 2.35 and a p-value of 0.03, which is below the significance level of 0.05. As a result, we reject the null hypothesis, indicating a statistically significant difference in test scores between the groups, suggesting that the new teaching method may enhance student performance compared to the traditional method. However, due to the small sample sizes, caution should be exercised in generalizing these findings. Future research with larger samples is recommended to confirm these results. Overall, these findings contribute valuable insights into effective teaching, highlighting the potential benefits of innovative approaches in education. Yeah, this is my today's presentation. Thank you all for watching my video. Please do like my video and subscribe to my YouTube channel. See you all in the next video. Till then, take care. Bye.